Hi, my name is Bai Gaspard. I will walk you through this tutorial to develop an exploit from scratch using Python 3 and exploit the vulnerability found in SLMAIL server version 5.5 running on Windows 32-bit. So this is my lab machine where we are going to test our exploit, crafted exploit. We will craft it by ourselves actually from step by step, and we will also need to use some other tools. Some of them I will show you, but before, let's find what is the IP address of this machine. Then we will use this because we are going to reconnect to it via remote desktop from our attacker machine. So it's .93. Let's save it. Now we run our show you the requirements. The requirement you can use any debugger, but I would prefer Unity debugger because of a special Mona script that we are going to use, and I'll tell you why. An attacker machine, we are already using it. SLMAIL server version 5.5, of course, and some script from metasploit like the pattern create, used to create patterns, pattern offset, and the nasm script. We are going to see their use very soon. Okay. So let's first scan. If for example we are online, we can scan with nmap, using nmap -p. We know that SLMAIL is running POP3 server, so POP3 is having port 110, and we don't want it to be pinging, so we put 241.1.93. Of course, the the port is closed because the server is not running. So let's connect to remote desktop. Remote desktop, okay, -u, victim minus password 2.123 and 241.193. Excellent. So we are connected to the remote Windows 7. Sorry. Let's connect to our attacker machine via PuTTY that I already downloaded on the PuTTY official website. But the IP address, IPA, of this is 10.83. The 10. We will use this root. Oh, sorry. Let's first enable root login on our remote machine. SSHD config. So permit root login, yes. So we change it to yes. Yes. So service SSH restart. Let's try again. Root. Great. Excuse me. So we are logged in to our Kali machine. Let's run our SLMAIL server as root, as admin, sorry, 'and' then we start it. And 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 then we start it. good. So let's try to run our nmap minus p 10 minus pn 10.2.41.193. It's open now. It's open because we have started our server. Excellent. So we will run our immunity debugger as admin, and we will attach to this SLMAIL server. SLMAIL, where are you? Great, this is excuse me. Okay. Sorry, let me run it again. Attach SLMAIL. Is it already running? Okay. Why is SLMAIL not appearing here? Okay, let us restart SLMAIL. Start. We run our immunity debugger. I hope we are at what is open. Okay. So we attach it again. SLMAIL. Great. Expand. CPU registers. Let's arrange it. Appearance. I want it to be this format. And I don't know why it's appearing like that, but okay, great. This is what I was looking for. I see. It's overflowing. Okay, no problem. I'm going to maximize just as we have enough space. Okay, so appearance, let's take this as K16, and then appearance font is this one. Okay, so by default immunity debugger pauses this, so we will click here to enable the SLMAIL to continue running. So we are monitoring what SLMAIL server is doing. At the same time, we want to cd. So I wrote a small Python script connect to the remote machine. Let me change it. Okay, but the Python script uses socket communication, TCP, to connect to the remote machine. If the buffer size, the length of the buffer size is less than or equal to 30, we append in Python, we call append a times the counter here initially says 100. We append the counter, so it means the layman's understanding is each time we send a specific number of bytes, and then the SLMAIL server doesn't crash, and we add again the number of 200. We add 200 to the counter, and then we multiply it to the number of A's. Like we multiply the counter, the resulting counter, to the A's, so that we can, if we send 10, and then we are sending the next one, it will be 10 times the counter, which was maybe 200. It multiplies and so on and so forth. It grows in that form. So all these connections for connecting to the mail server on that port 110. Sorry. But here our IP is 10 excuse me, 10.241.1.93. Great. So let's run this Python. We run this and we observe what is going on. Great. You see how it's increasing? It's running. At a certain point, it will pause here. Excellent. It paused because it crashed at 2,700 bytes. So at this level, this one is a print statement. The command is not yet executed, so it is just printed, but the command is not yet executed. The reason why I'm taking the previous one. So we realize here that our series of A's has overflown the ESP. This is the stack. The ESP is the stack because each function is creating a stack, and then we have the ESP and the EBP. The EBP is the base pointer, and then the ESP is the stack. These are registers. E is 32 and R is 64. So what we are most interested here is the EIP, the instruction pointer. 41 is the hex equivalent of A. So 41 has been AAA has overwritten this. So if this instruction pointer tell to the CPU what instruction to execute next. So if we overwrote this address, it means it's very dangerous, because we can craft our address here to point to a specific shellcode that can be executed. Okay, great. So we succeeded to understand that there is a buffer overflow vulnerability on SLMAIL here, from here, and it is at the stage at the 2,700th byte. Let's improve our shellcode, but we need to restart this so that we can run our debugger from, and then we attach it again. SLMAIL. Okay, great. So let's go back to our putty. We need to improve exploit. So we know that our buffer, it's our at the 2700th byte we cause buffer overflow. But where exactly is the what are the 4 bytes? What are the 4 bytes that constitute the address of the EIP? So for that, we are going to use, I told you we are going to use a lot of script. We are going to use pattern create, locate pattern underscore create. Okay. Search. So this script here is a metasploit, you can see framework. It's a script, it's a Ruby script. You can invoke the -h to know what it does. MSF create option example, it creates a pattern of hex such that we can use it to in our exploit development. So -l and so on. We will we want to create a pattern of 2700 because we need to be sure that that our exploit is actually causing buffer overflow at 2700 byte. So we will run a crafted -l 2700. We will run that to see that to validate our thoughts. Then once we validate our thoughts, we can now proceed to know exactly at which address this is. Okay, it created, copied, and then copied, so I can modify my Python script, the buffer, of course. So let me remove all this because we are not going to use them. Buffer is equal to paste, and we save. Okay, great. So now we try again to run our Python exploit to see if it will crash, but before, remember, we have to start our SLMAIL server. Sorry, I forgot to improve it properly because it's counting the number of bytes. Okay.